Good morning, children. I hope you all saw the correction that I gave for this regarding this question. Describe with the aid of a diagram some form of fuse which is used in the electric lighting circuit. Okay, because it is as some form of a fuse, it's enough if you draw cottage type fuse. Okay, this diagram, it would have taken a long time. Usually the diagram doesn't come. If at all it comes, only cartridge type fuse they ask. Okay, so you can draw and practice this diagram. That is enough. Okay, now we go to the next one, that is switches. Okay, the next topic is switches. Okay, so you all know what is a switch. It is an on off device for current in a circuit or in an appliance. So it's basically an on off device. It is connected in the live wire. Okay, it helps us to keep the circuit on or off. Okay, now basically there are two types of switches. One is called single pole switch and the other one is called double pole switch. Single pole switch is used in appliances to start or stop the flow of current. A single pole switch disconnects only the live wire. Okay, whereas a double pole switch, a single pole switch will be like basically what is a switch? Switch is something like a pole. Okay, now this one can make contact or this one can break contact with that. Okay, so when there is a contact made, then current flows. When the contact is not made, then the current doesn't flow because there is a gap here. Okay, so as you know, live, neutral and earth. There are three wires: live, neutral and earth. Now in case of double pole switch, single pole switch means there will be only one switch on the live wire. It's enough if we put a switch on the live wire, because if this is open, current is not going to enter and the circuit will not work. But for safety sake, especially the main switch is usually a double pole switch, in the sense it will have poles on both live and neutral. Okay, so at a time when you switch it on, both will make contact. When you switch it off, both live and neutral will be cut off from the supply. Okay, are you able to see the difference? In single pole, only the live will be cut off. Okay, the pole will be only on the live. In double pole, there will be a pole on live and neutral, and when you are closing it, when you are offing it, both these poles will be raised up. So live and neutral both will be cut off from the current. In this case, neutral is still connected, but you know that current has to enter through this and has to come out. This is just the return path. So even if it is kept on, it is okay. But this is for an extra safety purpose that they do like this. So these are the two types of switches: single pole switch and double pole switch. Okay, now the next thing we have to see is switch is always connected to the, so a double pole switch disconnects both the live and the neutral wire simultaneously. Next one, switches are always connected in the live wire. Switches are always connected in the live wire, like how we saw for fuse. Okay, why it should be connected in the live wire? Because live wire is at high potential and current enters through this. So if you put a switch here, then only it will help in cutting off the current when you keep it off. Okay, mark these points. Give reason for connecting it in live wire. The points: first one, the appliance gets connected to the high potential point through the live wire. and current flows in the appliance because the circuit is complete, as the neutral wire provides the return path for the current. Okay, second point, in the off position of switch, the circuit is incomplete and so current reaches the appliance through the live wire. No current reaches the current through the live wire, so the appliance does not operate. Okay, when the switch is on, high current reaches the appliance and so it works. When the switch is off, no current reaches and so it does not work. Okay, now the next thing you should know is what will happen if the switch is connected in the neutral wire. What will happen if the switch is connected in the neutral wire? So they've given the diagram here. Okay, so this is in the on position. On position, no problem. Off position, when it is in off position, the bulb may not glow, but as we saw in the fuse, the the appliance is connected to the live wire. You might be thinking the switch is off and you might be trying to touch this point, and then you're going to get a shock because this is still at a high potential. This is not cut off from the supply. Only this is cut off anyway. Okay, so this is still at high potential. 220 volts is still coming there. Only that there is no return path, so current is not flowing. Now if I touch it, I provide a return path for it. So current will start flowing through me and I might get a shock. Okay, so in the on position, it allows current to flow in the bulb, and in the off position, no current passes through the bulb. Thus, the switch serves its purpose. But in the off position of the switch, the appliance remains connected to the high potential. In this condition, it is not safe to carry out any repairs in the appliance because on touching the live wire, the current will pass through the body of the person and he might get a fatal shock. It will work as a switch in the sense it will do the work of on off. Okay, in this case bulb will be off, in this case bulb will be on, but in this case even though bulb is off, that function is solved, but still it is dangerous because by any chance if we happen to touch this live wire, you can get a fatal shock. So this is the these are the two things you should know. Okay, three things basically. Types of switches. So usually in types of switches, if there are 2 points. Single pole switch, this is used in an appliance. Appliance means in a geyser or a heater or something to start or stop the flow of current. Okay, whereas double pole switch, if you see, the main switch at distribution board, only the main switch near the distribution board, that's where the current enters your house, that is only double pole. All the other switches that you see inside the house, they're all single pole. So double pole, first point will be it is mainly connected at the distribution board, and then the second point, it switches or disconnects both live and neutral wire. Here it disconnects only the live wire, here it disconnects both live and neutral wire. So that's one possible question. Then why should it be connected in live, and then why should it not be connected in neutral? Then you have some precautions that you all are very familiar. It should never be touched with wet hands because if water reaches the live wire, it forms a conducting path between the hand and the live wire, due to which current passes to the hand and the person may get a fatal shock. Okay. The next one is staircase wiring or dual control switch. I hope you would have come across this. In the staircase, like you will switch the light on from below, you will climb up the staircase and switch it off from above. In the sense, one bulb is controlled by two switches. That's called, okay, one bulb is controlled by two switches. That's called staircase wiring. But this is cut from the syllabus. Okay, so happily you can strike this off. Okay, and then we go to the next topic straight, that is earthing. So far we have seen fuse, then we saw switch, now we are going to see earthing. Earthing is another safety provision that is provided in a electric circuit that helps to protect the appliance from any kind of damage or anything. Let's see that. So what is earthing? this is an extra wire for the purpose of safety. Okay, so I told you there are three wires basically: live, neutral and earth. Basically we need only live and neutral. Current has to enter through this. Okay, and for a supply appliance to work, you need a path to go in and a path to come out. So this is enough to work. This is an additional feature provided for protection sake. Now suppose, imagine this is an appliance. Okay, this is a maybe water heater, heating rod or something you can take. And so one end is connected to the live, other one to the neutral, and the earth wire will be connected to the body of the appliance. Earth wire will be connected to the body of the appliance. Mostly all these are metallic bodies. All the bodies, all these are metallic bodies, be it microwave, be it heater, everything will have a metal body. Okay, so a wire will be going from the metal body to the earth. Now so all the earth wires, okay, like this, from every room, from every appliance, the earth wire will be all connected at one point. And what they'll do is, okay, basically they'll send this wire deep inside the earth, deep inside the earth. So not this wire, actually they'll put a thick copper rod. Okay, thick copper rod kept surrounded by some insulating cover. Okay, some insulator cover. And then at the end this will have a copper plate. This will be stuck to a copper plate, and this structure will be hidden, means it will be inside the ground. Now for every appliance they won't do this. So all the wires coming from the earth appliance, so this is a heater. Okay, then you have a refrigerator. From refrigerator one earth wire will come. Okay, and from another geyser another earth wire will come. Now all these earth wires are connected together, and near the junction board, you know what is the junction board? Near the distribution box. Okay, in the entrance of your house you have this board where the meter is kept, okay. Now in that place, this is done during the construction. You can't see this now. While they are constructing the house itself, near that KWH meter, that is the electric meter, they'll dug a deep hole inside the earth, under the earth, and then they'll put a copper rod surrounded by some insulator covering, and the end of this rod is connected to a plate kind of a thing, and this is surrounded by charcoal and a mixture of charcoal and salt, so that it forms a good conducting layer. Okay, so basically what will happen is, this high current will flow through this. Okay, whenever there is a high current, it will go to the earth, and that way the person touching it will be protected from a protected from the shock or any other damage. Okay, so charcoal and salt will provide a conducting path. They'll basically keep, the point is the extra current that comes should go into the, okay, this is the sand or the soil or the rock or whatever it is, so it's not a good conductor, so they provide this medium. Okay, sometimes they keep pouring water into it, so that the water will also help in conducting this extra current to the earth. That way anybody who is touching this will be protected. Okay, how it functions we'll see later. Let's see this. This is called local earthing. Okay, near your kilowatt hour meter, near the meter, they will do this thing. Okay, a hole nearly 2 to 3 meter deep is dug in the ground. A copper rod or a thick copper wire covered by a hollow insulating pipe is inserted in the hole. That's point number 2. Okay, describe about the local earthing. Is done near the KWHR meter, and then a hole nearly 2 to 3 meter is dug. A copper rod A really thick wire covered by a hollow insulating pipe is inserted in the hole. A thick copper plate of dimension 50 by 50 is welded at the lower end of the copper rod and it is buried inside the ground. That is the third point. Fourth point, the plate is surrounded by a mixture of charcoal and salt to make a good contact between the plate and the earth. Okay, to form a good conducting path, we can say. To keep the ground damp, water is poured through the pipe from time to time. This forms a conducting layer between the plate and the ground. Okay, this is how it looks, local earthing looks. Now, how does it protect? What does this local earthing do? If due to some reason, such as short circuiting, an excessive current flows through the live wire, it will pass to earth through the earth wire if there is local earthing. Otherwise, the line wires may get overheated and it may cause fire. Okay, now earthing of an appliance. Okay, the same thing. If there is any high current flowing through the line wires, then if there is an earth connection provided, the extra current will go to the earth and that way you can be saved. Now, earth is considered to be a enormous sink. It can take any amount of charge and it can also give him any amount of charge. So that way earth will never get a shock. Okay, it can take any amount of charges. Okay, come to the main thing. Okay, earthing of an appliance. As I told you roughly, if suppose you have a heater or a geyser or something, okay, a heater, okay, this is the this is the coil that gets heated up. So this is the live, this is the neutral. On the live you'll be having a switch and then you'll be having the fuse. Okay, this is the switch, this is the fuse, and then this is the body of the appliance. This is the body of the appliance. Now actually you can imagine this is the main part. The filament part is the main part. One end of the filament has to be connected to the live wire and the other end. Now you know that this being copper and this body being metal, if I just connect it, again there can be a contact. That's the reason why a wire is always surrounded by a plastic cover. You would have seen that. You don't see a copper wire generally outside. It is always surrounded by a plastic casing. Okay, so that is the reason why, because so here there is this metal rod should not directly touch this copper wire. So there is a plastic wire between that helps as an insulator, preventing contact between this and this. You want this neutral wire to touch only this other end of the coil. You don't want it to touch the body of the appliance. It being a metal, then it will start conducting and there can be. Now why is it problem touching the, it should not touch the body? Because body of the appliance is the part that we often touch. We don't touch the filament, we don't touch this coil part, right? This is hidden inside the appliance. But this body part, if it's a microwave, we need to open the door and close. If it's a refrigerator, we need to open and close. Geyser, okay, we don't touch so often, but still under some condition you have to bring down the geyser or do something. So the body of the appliance, we are in constant touch. So this body of the appliance being a metal, it should be very careful. You should be very careful that this doesn't touch the live wire, because live wire is at 220 volt. This is 0 volt. Okay, so that 220 volt will pass through the body. So that's why it is kept insulated. But what happens is with time, okay, maybe I've been using this appliance for 10 years. Now this insulator might melt off. Okay, this would get melted. Okay, sometimes it gets heated off, and so this insulator part melted. So what happens? This wire started touching this body of the appliance. This wire started touching the body of the appliance. Now one fine day, like when it started touching, and I'm here, it's a microwave or something, I'm opening the door of the microwave. Now when I touch, what will happen? This high current will flow through my body. Okay, suppose this is the door part and I'm touching it. Okay, this high current from here, it will come like this and flow through my body, and then I'll get electrical shock. Okay, so to prevent this, the body of the appliance is connected to the earth wire. Okay, so By chance, if there is, this is called short circuiting. No, this is not short circuiting. By chance, the live wire comes in contact with the body of appliance due to wear and tear. With usage, this plastic thing has gone off, so it isn't coming in touch with that. And if I happen to touch the body, this high current can flow through my body. I might get a fatal shock. Okay, if I touch it, okay, suppose this is me, and okay, um, hand is here. Okay, if I touch it, then this high current can now, if it would not have been earthed, then this high current has to flow through me, and because I'm standing on the ground, there is a path, and then I will get the shock. On the other hand, if I would have connected this body to the appliance, to the earth wire, you know what is earth wire? There is a copper wire going deep inside the earth and all that. So by chance, when that thing happens, okay, now the current which comes here has two paths. It can either go to the earth or it can go through your body. Actually, earth is considered to offer zero resistance. Earth is considered to be zero resistance in the sense it is like a sink. Okay, so your body still, when compared to that, our bodies might still offer some resistance. So the current coming here won't choose this path, it will choose this path because there is a path of zero resistance. There is no obstruction, and it will quickly tend to go into this and go to the earth. That way, even though you touch, you will not get the shock. Hope you got it. I hope you understood it, children. This is the purpose of earthing of an appliance. Mainly the body should be earthed so that when this live wire comes in contact with the body, and if you happen to touch the body, you might get a shock. To prevent that, that body of the appliance is connected to an earth wire so that when there is a leakage or this current will go to the earth and you will be protected. And when they are connecting this body, now usually the body of the appliance outside you will see painted. Okay, refrigerator, you will see what you see outside is a paint coating. There is a metal inside, but the what you see outside is a painted one. So where they are connecting the earth wire, they'll remove the paint. Okay, because paint is an insulator. At that point alone, they'll remove the paint and then they will fix it. Then only contact will be made. Okay, that's why they have shown this kind of a scraped thing they have shown. Okay, so this is the diagram for earthing of an appliance. Okay, so there is an element of an appliance, there is a fuse switch on the live wire, and they have shown this also to show the insulator. This should not touch the body. There is an insulator in between, and this is neutral metallic case of the appliance. This is the earth wire. Now it is essential to provide a connection for earthing an electrical appliance such as refrigerator, toaster, geyser, electric iron, electric cooler, etc. while we handle physically. These appliances have their metallic case and are provided with a terminal on the case. The earth wire of the cable is connected to the terminal. Shows the live and neutral wire connected from the source of the element through the insulating plugs in the metallic case. The switch and the fuse are connected in the live wire. The earth wire is connected to the metallic case. Now this is the symbol used for earthing. Okay, the symbol that is used for earthing is like this. This is the symbol used for earthing. Okay. Most often the metallic case of the appliance is painted. The paint provides a insulating layer on the metallic body. To make the earth connection, it is necessary to remove paint from the body part where connection is made. Exactly where you are making the connection, at that point they will scrape off the paint part so that direct contact is made between the metal part. Okay. Now comes the main thing. How does earthing offer safety to the appliance? First point, when the live wire of a faulty appliance comes in direct contact with the metallic case due to break of insulation after a constant use. Now this happens when you have, that's why when you've been using it for a longer time, that's why they say you have to keep changing the wires in this often, because anytime this insulation can go off. So after a constant use, the appliance acquires the higher potential of the live wire. Second point, a person touching this So that's the first point. Then this is the second point. A person touching it will get a fatal shock because current flows through his body to the earth. Third point. But if the metallic case of the appliance is properly earthed, then as soon as the live wire comes in contact with the metallic case of the appliance, a heavy current flows to the earth through the case of the appliance. Okay, because metallic case has zero resistance. Because it is connected to earth, it has a zero resistance. Fourth, then the fuse connected in the circuit blows off and the appliance get disconnected. Okay, this way you are saved. Okay, by connecting this earth, the current doesn't pass through you, it passes through you. Also, the appliance has to be saved. Okay, or high current can flow through this also. So what happens when this contact happens between live and, so high current flows and the fuse will automatically break. Because a high current flows, fuse will automatically break. So that way this appliance is also cut off from your life and the appliance is protected. Okay, two ways it protects. One is it protects you from getting a shock. The other one is it protects the appliance from getting a high current and then melted off, or it can get melted or blasted off. Okay, that's why the fourth thing what happens is the fuse connected in the circuit of appliance blows off and the appliance gets disconnected. Thus, the person touching the defective appliance does not get any shock and the appliance is also saved from being damaged. So, twofold advantages we get. One is you are protected from shock and the other one is appliance is protected from um, blasting off or from the element melting or something. Okay, appliance can blow off. Okay, um, appliance saved from being damaged. Okay, so this is how earthing offers protection. So there are, one is local earthing, how do they do at a particular place, and then this is earthing of an appliance. If they ask you how does earthing offer protection for an appliance, specifically for an appliance, this is okay. This is about the local earthing. This is about the local earthing. So see the question properly. And safety by earthing of an appliance, it's always better to draw this diagram. It is easy to explain with this. I hope you have understood this. Okay, children, I'll be giving some questions. You can write the answers and send it to me. Thank you so much.